All right, hey, C++ paper cuts. My current day job is now again a C++ role. Hurts. I've been there. I recently had that happen like 6 months ago, where I had to go back into C++ land for a while. Always is emotional bruising. And so I find myself yet again focusing on this blog post on the downsides of C++. Overall, I have found returning to active C++ dev to be exactly what I expected. I still have the skills and can still be effective in it, but now I have worked in a more modern programming language with less legacy cruft. The downsides of C++ sting more. Isn't that funny how that is? Like when I used to program for IE 7 and 8, IE 8 felt like a godsend, IE 7 felt horrifying. I think the rest is very, very obvious. As your environment and things become more modern, the feeling of pain becomes more real. There are so many features I miss from Rust. Not only the obvious safety features. This one I feel like the quote-unquote safety features. Just throw things in unique pointers and shared pointers, and you have like 95% of what you got from the borrow checker. It's pretty nice. Or even primarily those, but also features that C++ could easily add, like some types called enums. I mean, you just have less convenient syntax for this. I mean, you still have that. You just have to make a little union type discriminator and boom, you got it, right? It's annoying, but I get it. I get it. Or first class support for tuples. But it doesn't quite have the same... It's definitely more dangerous. I agree with you. It's more dangerous. It's more dangerous. Or first class support for tuples. Actually, I do like tuples. Tuples are glorious. Tuples are glorious until I use them. I swear every time I use a tuple, that .0 and .1 syntax triggers me. It just triggers me. You know, you use a tuple because it's convenient, and then after you get done using a tuple, you realize a struct is no different than a tuple, but it just has nicer names. And you go, why am I using that? Smart pointers are slow. This is true. Smart pointers are much slower. You're absolutely right. But so is the 1,000 calls to .clone in my Rust program. Okay? That also is very slow. That also is extremely slow. So it's like, which slow do we want to use? I don't know. Which slow would you like to use? I'm just saying. I'm just throwing it out there that I agree that having a compiler check the unique pointerness of things is much better, but they are slower. Before I start getting into the paper cuts, though, I want to address one of the primary defenses I've seen of C++, one that I have found particularly baffling. It goes something like this. C++ is a great programming language. Okay, that is baffling. I don't know anybody that says this. Like, I don't know anybody other than game devs that say this. Okay, this is a very strange take. What is this? The complaints are just from people who aren't up to it. Wow. If they were better programmers, they'd appreciate the C++ way of doing things, and they wouldn't need their hand held. Languages like Rust are not as helpful for such true professionals. The thing is you can make the identical argument for Rust. You start using Rust, and you make some bad design decisions early because you don't understand, and then you get into this point where your program becomes just unmaintainable without a full rewrite because you've just done up the Rust way of doing things. And people are like, well, if only you understood the idiomatic Rust way of doing things. Again, it's all skill issues in all languages. That argument is just a snooze fest. It's always been a snooze fest. It will always be a snooze fest, and it exists in every language. It's just some make it easier for you to go longer with your bad decisions. And I think that that's a good thing. Okay? I'm going to throw that out there. That's why I think Go is so successful, because you can go longer with a bad decision than you can in Rust. Think about that for a second. Obviously, the phrasing is a bit of a parody, but I have seen this sort of attitude so many times. The most charitable view I can take of it is that a claim that C++ difficulty is a sign of its power and the natural cost of using a powerful programming language. What it reads like to me in many cases, however, is a form of elitism, a general idea that making things easy for poor programmers is pointless. That's why we invented JavaScript, okay? You let the poor programmers use JavaScript. I'm getting canceled today, boys! And that good programmers don't benefit from making things easier. As someone who has programmed C++ professionally for a majority of my career and who has taught company internal classes in advanced C++, this is nonsense to me. I do know how to navigate many paper cuts and footguns of C++, and I'm happy to do so when working on a C++ code base, but experienced as I am, they still slow me down and distract me, taking focus away from the actual problems I'm trying to solve and resulting in less maintainable code. Yeah, I agree. It sucks. I am no defender of C++. As for the upside, I see very little. Any way in which C++ is more performant or more appropriate than Rust in terms of platform support, legacy codebases, optimization that are only available in specific compilers that often or that happen to not support Rust, or other concerns irrelevant to the actual design of a programming language. I mean, there are a lot of things that are very nice. You know, like when you're doing an array of structs and you're mutating and you're playing around, the amount of dancing and things you have to do in Rust are not as much as you have to do in C++. Granted, there's more foot guns, but there's things you can do in C++ that are just simpler problems to solve than you can do in Rust. While I'm proud of my C++ skills, I am not too proud to appreciate the better technology can render them partially obsolete. And I'm not too proud to appreciate having features that make it easier. In most cases, it's not a matter of programming languages doing more work for me, but of C++ creating unnecessary extra make work. Yeah, this is perfectly reasonable take. Often due to the decisions that made sense when they were made, but not long since stopped making sense. Don't get me started on header files. Yeah, header files are a bit emotional for me. Me hates it. I do want you to know that I'm not ragging on Rust. It's just that I think that people with excellent C++ background are the worst Rust is the greatest people, because you can almost virtually transfer all of your thoughts about C++ onto Rust. You know what I mean? The reason why header files suck is that it's called a module. Why do you need to define the same thing twice? What the hell are you doing defining things? Right? It literally makes no sense that you have a file that says, here is what my class looks like, and then you have another file that says, here's how you implement it, and yet it's for better compilation speed. You know what's way cooler? Single pass to create the header, second pass to create the thing, okay? It's called a 2-pass compiler, or a 3-pass compiler, or an n-pass compiler, okay? They've been doing it for years. Somehow I'm able to state several functions that will be used, and it doesn't have to compile the whole gosh darn thing to figure out what the hell I'm exporting, right? It doesn't have to be crazy. Yes, 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 and header file still has all the private members of the class inside. If I remember, C++ is 7 passes, which is crazy. I don't know if that's true, but that's wild, right? Single pass, you can get the shape of things, right? You can make these decisions. You don't need something to tell you what's already available. But I also want my programming language to be beginner-friendly. I'm always going to work with other programmers who have a variety of skill sets, and I would rather not have to clean up my colleagues' mistakes or mistakes of earlier, more foolish versions of myself. If making a programming language more beginner-friendly sacrifices power, then I agree that some programming language should not do it. Yep. I agree with that. Go is a great language for this, but many, even most of C++ beginner, unfriendly, and expert annoying features do not in fact make the language more powerful. So without further ado, here are the biggest paper cuts I've noticed in the past month of returning to C++ development. Love it. Love it. Const is not the default. Yeah, I do agree. I think that this is probably a better way of doing things. I do like the idea of specifying mutations as opposed to specifying constantness. I think that's a better trade-off to make. And remember, with JavaScript, you have to do a const, right? They're const pointers. They're not constants. So it's like a double one. You got to be extra careful. It is very easy to forget to mark a parameter const when it can be. You just forget to type the keyword. See, that's the thing, is you never forget to type the mutation word, but you will always forget to type the const word. It's very, very true. This is especially true for this, which is an implicit parameter. There is no time when you are typing out this parameter explicitly, and therefore it won't sit there looking funny without the appropriate modifiers. If C++ had the opposite default, which every value, reference, and pointer was const unless explicitly declared mutable, then we'd be more likely to have every parameter declared correctly based on whether the function needs to mutate it or not. If someone includes a mutable keyword, it would be because they know they need it. Yes, it actually, I love this take, by the way. I think this is one of the big wins of Rust and other languages like OCaml. OCaml pioneered it for Rust. I'm sure there's languages OCaml got it from. If they need it and forget it, the compiler error would remind them. Exactly. Exactly. You want the compiler to tell you when you're wrong, and this is beautiful. Now, you might not think this is important because you can just not use const and have functions with capabilities they don't need, but sometimes you have to take things by const in C++. If you take a parameter by non-const reference, the caller can only use L value to call your function. But if you take parameters by const reference, the caller can use L values or R values. So some functions, in order to be used in natural ways, must take their parameters by const reference. Once you have a const reference, you can only easily call functions with it and accept const references. And so if any of those functions forget to declare the parameter const, you have to include const cast or go to the function later and correctly accept const. Unless you think this is just a sloppy newbie error, note that many functions in the standard library had to be updated to take const iterator instead of the addition to iterator, when it was discovered correctly that they made sense with a const iterator. Functions like erase. It turns out that for functions like erase, the collection is what has to be mutable, not the iterator. A fact that maintainers of C++ libraries simply got wrong at first. That's pretty impressive to get that wrong, right? Obligatory copying. Sounds like, are we talking about Rust now? Is this Rust? Are we talking about Rust? In C++, for an object to be copyable is default. Okay, I do actually agree with this. I hate the fact that default is copy. There's something so effing emotional about the fact that when you take a vector and go const A equals this vector, const B equals A, you got yourself a copy. And there's something, I agree. I have chased down many a bug has been due to that one thing. Just hurts. If you don't want your object to be copyable and all of its fields are copyable, you often have to mark the copy constructor and copy assignment operator as equal delete. The default is for the compiler to write code for you. The code that can be incorrect. Yeah. If you do make your class move only, however, beware, because that means that there are situations where you can't use it. In C++ 11, there is no ergonomic way to do a lambda capture by move, which is usually how I want to capture variables into a closure. No! Similarly, the standard function expects the object it manages to be copyable and will fail if your closure object is move only. This is going to be addressed in C++ 23, which should come out in 2033. With standard move only function, but in the meantime, I have been forced to write classes with a copy constructor that throws some sort of runtime logic exception, and even in C++ 23, copyable functions will be the default assumed situation. I love runtime exceptions for things that should not be runtime exceptions. Feels good. Using standard function, not like this. This is strange because most complicated objects, especially closures, are never and should never be copied. Generally, copying a complicated data structure is a mistake, missing a AND or a missing standard move, but it is a mistake that carries no warning with it and no visible sign in the code that a complex allocation-heavy action is being undertaken. This is an early lesson to new C++ devs. Don't pass non-primitive types by value. But it's possible for even advanced devs mess up from time to time, and once it's in the code base, it's easy to miss. Agree. This bites me at least every time I start back up in C++. This bites me once. I mess up something, and it takes me like a good old-fashioned GDB/printf time to figure out what the hell did I do wrong. By reference parameter paper cuts. It is unergonomic to return multiple variables by tuple in C++. Everybody loves standard tuple. Come on. It can be done, but the calls to standard tie and make tuple are long-winded and distracting, not to mention that you'll be writing unidiomatically, which is always bad for people who are reading and debugging your code. As a result, C++ often resorts to out parameters. I love that C# so thoroughly loved the idea of out parameters. You actually have an out keyword so that you can have out parameters in C#. Chef's kiss on making hard code. In this, as well as other situations, you end up taking a parameter by non-const reference, meaning the function is supposed to modify the parameter. The problem is this is only marked in the function signature. If you have a function that takes a parameter by reference, the parameter looks the same as by value parameter at the call site. Really? Return false on failure. Modify size with actual size message, decreasing it if it contains more than one message. Message nice? Dude, who abbreviates message like that? Okay, can we just time out this entire thing and just realize that this is that I personally have some problems here? Okay? I got some problems going on here long before any of this is taking place. You know what I mean? That is cursed. It is cursed. Messagey. That's totally unhinged. Dude, it's totally unhinged. If you're reading the calling code quickly, it might look like the resize call is redundant, but it is not. Size is being modified by got message. The only way to know that it is being modified is to look at the function signature, which is usually in another file. Yeah, I do agree. Again, specifying mutations are better than specifying constants. I think it's just generally accepted that it's true 100% of the time. Some people prefer out parameters, in and out parameters to be passed by pointers for this very reason. I can purchase that. This is great, or would be if pointers weren't nullable. What does a null pointer parameter mean in this context? It is going to be, is it going to trigger undefined behavior? What if you pass a pointer from a caller into it? People often forget to document what functions do with a null pointer. Options are just a great way to type system specify this, and I love it. This can be addressed with non-nullable smart pointers, but very few programmers actually do this in practice. We kind of require ourselves at Netflix to do this. Smart pointers are great. In general, they're great. Yeah, they're a little bit slower, but you know what's really slow? Debugging. That's really slow. Okay, that's emotionally slow. You know what's even slower? The JavaScript we're running underneath. Okay, now that's where the real slowness happens. When something isn't the default, it tends to not be used everywhere where appropriate. The sustainable answer to this is changing the default, not heroic attempts to fight human nature. Fair. Obligatory side gripe. At least in non-owning situations like this, it is possible to write such a smart pointer. However, if you want to write the obvious companion, a non-nullable owning smart pointer, a companion version of standard unique pointer, then it cannot be done in a useful way because such a pointer cannot then be movable. I don't quite understand that. This man has too much C++ power for me to understand. Method implementations can contradict. Ooh, this sounds exciting. Just always write the code correctly the first time. LOL, 4 head, 5 head, 1 head. I refuse to use smart pointers. Interesting. Really? You refuse to use them? Is it because of the atomic incrementer? I wish there was. Like, one thing I say that Rust also does very well is not allowing non-atomic pointers to be passed between threads. I think that's a really nice thing because that way you can have a literal +1, a very simple, smart pointer, the RC, to be passed around, and then you have the more costly arc when you need something, right? Smart pointers are awful. They're not that bad. Awful is a pretty intense word for it. They're not great. Okay, I prefer having my compiler be a smart pointer, but awful's a little intense. Yeah, if you have a C API, don't use a smart pointer. Anyways, all right. For many cases, for many classes, the default implementations are enough, and if possible, you should really rely on them, or you should rely on them. Whether or not this is possible depends on whether naively copying all the fields in a sensible way to copy the entire object, which is surprisingly easy to forget to consider. Absolutely. But if you need a custom implementation of one of these, you are on the hook to write all of them. This is known as the rule of 5. You have to write all of them, even though the correct behavior of the 2 assignment operators can be completely determined by the appropriate constructor combined with the destructor. The compiler could make default implementations of the assignment operators that refer to those other functions, and therefore would always be correct, but it does not. Implementing them correctly is tricky, requiring techniques like either explicitly protecting against self-assignment or swapping with by-value parameter. In any case, there are boilerplate and yet another thing that can go wrong in a programming language that has many such things. Wait until your friend implements a template for you to solve this problem. Gosh. Conclusion. Unfortunately, look at me. I'm getting all steamed up. I'm steaming right now. Unfortunately, I'm too well aware of why these decisions were made, and it is exactly one reason: compatibility with legacy code. C++ has no addition system, no way to deprecate core language features. If new addition of C++ was made, it would cease to be C++. Though I support the efforts of people to transition C++ to new syntax and clean some of this stuff up. Yeah, but Rust doesn't break backwards compatibility either. I think there's been one such case of a method being completely removed due to some gigantic security violation. But even with the additions, I don't think it removes anything, right? I don't think there's anything that says that it can't be undone. C++2 when? You should see C++23 before we talk about C++2, okay, buddy? But Rust is a new language. Yeah, I know. Rust is a new language that's expanding exceptionally fast. Just wait for this article to exist with Rust. It's going to happen, right? However, if you ignore backwards compatibility, it's going to go back to OCaml. It always goes back to OCaml. Don't worry. It's coming back. The arc's happening. However, not atomic reference counter, by the way. If you ignore backwards compatibility in the large existing code bases, none of these paper cuts make the programming language more powerful or better, just harder to use. I have seen good faith arguments in favor of human-maintained header files, surprising as that is to me, but I challenge my readers to tell me what is beneficial about C++'s design choice in these matters. I agree. You might find these things trivial, but these all slow programmers down while simultaneously annoying them. If you are experienced enough, your subconscious might be adept to navigate it, but imagine what your subconscious could do if it didn't have to. But how adept are you at seeing these mistakes in a code review from your junior colleagues? Impossible. If you are a rigorous reviewer, how much more time does it take? How adept are you at finding these issues quickly when a bug arises? These are great questions. Honestly, these are great things. Oh, Campbell sucks. You suck. Okay, you know what? We're not going to have this. You know what? This is 1984 going to happen right here. That message never existed. Get the hell out that message. What would be more effective? Let's see. We'd be more effective, more efficient, and happier if these issues were resolved. Programming would be both enjoyable and faster to do. What's the downsides? The only upside is continuity with history. And while I can see the value in that, it is very limited value with very limited scope. I agree. This is a great article. This is a great article on some of the C++ paper cuts. I really agree with the 5 one. That is the rule of 5. It is just so painful, and I've had it happen to me, and it's just like it can go terribly wrong. Okay, hey, C++ is cool, but man, does it have some foot guns? The name is the Foot Gun-agen.